Okay guys, now is the time to find out the marginal rate of substitution for a quasi-linear utility function, which is linear in one good and non-linear in another good. So in this case, it's non-linear in x but linear in y, which is the utility function is equal to ln of x plus by. So it's non-linear in x but linear in y, remember that. So then marginal rate of substitution is equal to the marginal utility of x divided by the marginal utility of y, and the marginal utility of x, as you know, that is equal to the partial derivative of this utility function with respect to x, and the marginal utility of y is equal to the partial derivative of this utility function with respect to y. So as simple as it is, let's go find out it. So the partial derivative of utility function with respect to x, as we know, our x term is a logarithmic form. So then the partial derivative of ln of x will be equal to 1 divided by x. And the partial derivative of this part with respect to x, as we don't have any x value here, so then will be equal to 0. So now the marginal utility of y, which is equal to the partial derivative of utility function with respect to y, this part doesn't have any y, so is equal to 0. This part have y, so the derivative of this part with respect to y is just equal to b. Is just equal to b. So now our marginal rate of substitution is equal to 1 over x multiplied by b over 1 we have here. So then it's equal to 1 over b. And finally, the marginal rate of substitution in this case is equal to 1 divided by bx. 1 divided by bx. This is the marginal rate of substitution for this quasi-linear utility function. You know that, remember this part, in case of quasi-linear utility function, our marginal rate of substitution depends on the value of a non-linear good. You know that? So we have non-linear good of x. So then the marginal rate of substitution depends on how much or how many good of x we have in our consumption. It does not depend on how much y, which is linear good, we have. As we saw in the case of linear utility function, the marginal rate of substitution did not depend on the value of x and y. So as we have linear on y, so it does not depend on the value of y. As we have non-linear in x, it depends on the value of x. So this is the quasi-linear utility function. In another way, we may have like this kind of utility function, which is equal to ux y is equal to, for example, ax plus by to the power of, for example, 1 over 2 to the power of 1 over 2. So now the marginal rate of substitution for this function m or s, which is the marginal rate of substitution for this one. So let's find out the marginal utility of x first, which is equal to a, then the marginal utility of y, which is equal to b multiplied by 1 over 2 y to the power of 1 over 2 minus 1. Then the marginal rate of substitution will be equal to a divided by b multiplied by 1 over 2 multiplied by y. 1 over 2 minus 1 is equal to minus 1 over 2. So then if you move out this one to the numerator, so then the marginal rate of substitution will be equal to a divided by 1 over 2b multiplied by y to the power of 1 over 2 to the power of 1 over 2. When we move out here, so the negative will change to the positive. So then the marginal rate of substitution in this case, as you see, it depends on the value of y. Y depends on the value of y here because y is nonlinear good in this case. In this function, x is nonlinear, so it depends on the value of x. In this function, y is nonlinear, so it depends on the value of y. And finally, the last conclusion is, in case of quasi-linear utility function, marginal rate of substitution depends on the value of nonlinear good. Either it's x or it's y. So as simple as it is. I hope to continue watching my videos in this YouTube channel to learn many things about microeconomics and other economics related subject. But don't forget to subscribe and hit the like button. And if you have any question, just write down in the comment. I will try to solve as soon as possible for you. See you guys next time.